Up next, I have the distinct pleasure of inviting Sunil Khandekar, who's the founder and CEO of Nuage Networks. So Sunil leads the vision and direction of Nuage Networks, a Silicon Valley-based business that brings a combination of technologies and networking expertise to both the enterprise and the telco enterprises. Sunil's been in networking for some time and building experience both in product management and consulting engineering across a wide variety of organizations, including Alcatel-Lucent, now Nokia, as well as the very successful startup by Metra Networks and Bay and Nortel too. So with that, let me get Sunil up here to talk about SDN's endgame. Sunil?
Thanks. Good morning, everyone. It's a pleasure always to be here at this conference. Remy and the guys do a great job. So SDN has come a long way in the last 5 years. I remember standing up here in 2012 and talking about the promise of SDN, about bridging the gap between applications and networks to make it more automated and consumable. At the time, there were more questions than answers, and certainly hardly any user experiences or deployment experiences. But since then, I think as an industry, we've come a long way, and we've tackled some big issues. At Nuage, we've been involved in over 200 different projects with various different large enterprises, service providers, for their private cloud automation, public cloud automation, or hybrid deployment, as well as SD-WAN, and of course NFV recently with a lot of service providers. Throughout this, as we have gained the experience, as we've worked and uncovered new use cases, it's become very, very clear that SDN is absolutely the most essential and the foundational piece in terms of creating and building a highly automated infrastructure. And dare I say, it's the right SDN framework that's critically important for us to ensure that we do bring the automation in not just the data centers, private or public, not just the branch, but together, we also don't forget the security. We must not leave security behind as we automate everything else. And that's one of the topics that I want to touch on today. But again, it has to be the right SDN framework. I'm not talking about namesake SDN or SDN controllers or open flow controllers, but an SDN framework that, as Vijay was saying earlier, allows for intent or declarative policy-based network automation across all the properties, because that is ultimately in support of SDN's endgame, which is what? To connect users automatically, quickly, and securely to the applications that they need to get to, whether it's in the private or the public cloud. So with that, let me get in and talk about, and I'll take it right from the top. As consumers, we are very used to, whether we are stationary or mobile, we are hyper-connected, and we have information at our fingertips. Not quite the case in enterprise networks, and the CIOs of enterprises have absolutely realized and come to the conclusion that they must modernize their infrastructure, and they must use IT as a competitive advantage. They must use IT to create new sources of revenue, to really simplify operations and compete effectively and reach more customers. And for that, they need to align IT to their business needs. And to the extent that they avail these services from the service providers, what they'd like is for the service providers to give them these automated services. And service providers are responding in kind. What the service providers are doing is they're transforming as well their services and network infrastructure and IT infrastructure while dealing with absolutely unabated bandwidth growth and also tremendous pressure overall and the challenges as everything starts to move to the cloud. And it's critically important for service providers to do that because there is a big disconnect in what enterprises want, which is they want to order and get instantly, instant gratification, and they want to only pay for what they avail, while what the services today are clearly about order and wait. And we need to really close this disconnect. So what are the initiatives that are underway? The key trends that are underway are software-defined data centers. Software-defined data centers is take the traditional data center and make it highly automated, highly programmable, highly agile. For which use cases? Hosting and public cloud. For NFV use cases. NFV is a use case for SDN. As well as adopt all cloud-native architectures. Yes, it's early in terms of containers, but that's a critical component of adopting the cloud-native architecture. SD-WAN. SD-WAN is certainly causing a massive disruption in the branch networking, which has stayed static for the last 2 decades. And it's exciting times in networking to be working on this technology. But remember, SD-WAN is about not connecting users to users. It's about connecting users to the application. And finally, software-defined security. As I said, we can't leave security behind. We must use the software-defined infrastructure and framework to also modernize and strengthen security. So with that, let's dive in. Here's the reality of today's data centers. It's got multiple hypervisors, and as a result, what you have is you have the ESXi hypervisor. So it's not about creating an overlay, a mono hypervisor automated overlay for just connecting all the VMs, virtual machines that are in the ESXi hypervisor. It's about dealing with various different, you got the KVM hypervisor technology, you got obviously the bare metal servers, and it's not about having an open flow controller to program the VTEPs or the switches. More and more containers are starting to show up. And then, of course, what you have is Hyper-V as another hypervisor technology. So what you have is the requirement for highly automated overlays to be connected, because what happens if the application requires that the web front end is using the containers, the business logic is using the virtual machines, and the back end is bare metal servers with Hadoop infrastructure. You have to have a declarative policy-based, intent-based network automation that allows for service overlays in a way that is completely independent of the type of workload. And it's also boundaryless. It allows for the workload and the policy to move with the workload. When the workload moves from a virtual machine to a container, the policy moves with it. Or the workload moves from bare metal server to a virtual machine, the policy moves with it. That's what is absolutely essential and critical to transform the traditional data centers to a highly automated public or private cloud, excuse me. And of course, not to forget that it must also provide for complete seamless automation with the orchestration systems, because there's multiple different orchestration systems, whether it's containers, which is showing up more and more, especially in a DevOps environment, as well as, of course, OpenStack and other proprietary orchestration systems. But at the end of the day, the call is one call to the SDN controller for automation across any of these, for any application across any of these workloads. So requiring total flexibility, any workload, any hypervisor, that's how you transform a traditional data center to highly automated, programmable, and agile cloud. So let's look at SD-WAN. So SD-WAN, and we all, and this is a fantastic conference, last 17 years we've been working on MPLS, VPLS, IPVPN technologies. The idea of those technologies was that the footprint or the diameter of the service was until the last PE router, because the service state is in the PE router. SD-WAN came along and said, you know what, we're going to push intelligence all the way to the customer prem. We're going to start the service right from the customer prem. What does that do? The PE router looks at only the IP packet, because the intelligence is at the very, very edge. That allows for your service to now suddenly use internet as the underlay. So you can use the internet or the private IP as the underlay to create a service that spans both. It becomes boundaryless. However, as Roy pointed out in the morning, The deployments are not all going to be greenfield. There never is a such thing as greenfield. So it has to be that you must require ability to seamlessly connect the SD-WAN overlay to the existing VPLS or IPVPN services. This is critically important. And by the way, this is the first use case that most service providers are tackling with, in addition to the hybrid use case when the bandwidth is required, where the enterprise customers want to use both internet as well as private IP. Next, it's about having the ability to really create this arbitrary, again, service overlays that have the affinity between each of the users and be able to apply a common policy, but have that total flexibility of any location, any service, any uplink, and do it in all combinations. That's great, but what about the cloud? Because almost every enterprise is consuming a public cloud in one way or the other. So the CIOs, what they want is to apply a consistent policy, network access policy that is consistent for all their branches, and they want to treat AWS and the VPC or GCE as just another branch. And to do that, you must have, again, this policy infrastructure and the right SDN framework to be able to create these service overlays that are end-to-end and they span across from any user location, any branch, to connect to the public cloud or the private cloud where the applications are. This is how you create automated networks without borders using the right SDN intent-based declarative policy automation. So with the right SDN framework, we solve that disconnect. And we make it aligned with the needs of the enterprises, which is order and get. All right, that's great. What about security? So let's spend some time on security. This is very, very, very important. So as more and more devices get connected, the surface attack increases, and there are millions of breaches. These are the numbers just from 2016. Over 500 million breaches. And look at the time, average time it takes to even detect one of those breaches. It's clear that the existing way of dealing with security is just not sufficient. Because what you have is, you have the protection, which is typically perimeter-based protection, with the target stores breach, which is a classic case study. It's apparent and very clear to enterprises as well as service providers that they must protect east-west traffic as well. But the traditional methods of using a firewall is just not scalable, and it's too cumbersome to have that be supported for east-west traffic. And there isn't enough ability to create segmentation automatically. The processes just aren't there. Same thing for detection. In terms of detection, when there's a fault, there isn't enough data available to detect anomalous behavior or something that is not supposed to be in terms of a certain rule that was placed or hasn't been placed for applications and users that shouldn't be talking to each other, that there's just an opening left there, and that's being violated. And the operations complex, extremely complex to have these ACLs, and then to do, enterprises spend millions of dollars every year, and so do service providers, in just managing and auditing their configurations to ensure that they're accurate. And to have this manual process of putting in ACLs just doesn't work. So how do we leverage the fact that SDN infrastructure has centralized the intelligence? There's domain-wide view of the data center as well as the branches. How do we use that infrastructure? Let's look at a few use cases. The first use case is about east-west traffic. How do you protect east-west traffic? So the simple answer is you create microsegments. You create microsegments, but the microsegments, again, shouldn't be mono-hypervisor because it would be too cumbersome. You should be able to arbitrarily group any workloads, whether it's container, whether it's an VM in a ESXi or VM in KVM or VM in hypervisor or bare metal server, and group them logically and apply a common policy to that and create that microsegment. So the right SDN architecture and framework allows you to do that quite effectively, quite easily. However, there's one issue here. And the issue is that you're leaving this infrastructure vulnerable to attacks from the branches. So, because typically what happens is the VPN stops at the edge of the data center, and then it's, everything is open once you are in the data center. So what you want is really create microsegments that have the affinity to the users and the applications that they are consuming. HR must only be able to talk to the HR applications, finance to the finance, marketing to the marketing applications. And what that means is that SDN automation and infrastructure and the microsegment has to start from the branch, any branch, and move all the way to the data center, any data center. And when the user moves to another branch, the policy moves with the user. When the workload moves from one data center to the other, the policy moves with that workload, so that the microsegment remains intact and the fidelity is always preserved. Okay, so another use case is about flow visualization and having contextual visibility. Why? Because oftentimes enterprises just don't have even the inventory of all the applications and the flows that are in the network. And how do you get that? So you leverage, I guess I need to move closer to you. So the way you leverage that is by having the ability to collect all the information, because when you are in the branch or in the data center, you are looking at all the traffic flowing through this at the data plane layer. So leveraging the DPI and leveraging big data analytics, you can provide tremendous visibility and contextual visibility, and that can be used for various different use cases. One, to simply start to become much more granular in the whitelist that the enterprises or the service providers generate, because they typically start with a very coarse whitelist policy. Once you have the visibility, you can make it much more granular. Second use case is you can detect anomalous behavior. If there's a port scan going on and the ACL thresholds of deny is going just through the roof, you get alerted. And as soon as the alert comes in, you can zoom in and figure out what is actually, which workload is the one that is actually causing or doing this port scan. And you can take automated action or you can take a manual action, but you can be very surgical about quarantining that particular workload quickly, because the intelligence is in the SDN controller and the policy server. And finally, the last use case, which is about dynamic service chaining. So what does that mean? It's about preventing malware from entering the corporate network or the service provider network, whether it's IT or NFV infrastructure. And how do you do that? How do you detect this? So once you have the ability to do this contextual visibility, and once you have that information in and leverage the analytics, big data analytics, you can do a couple things. You can have an automated policy that says, as soon as it goes over a certain threshold, you trigger a policy that starts to do one of two things. Either puts a fine-grained mirroring flow-based mirroring at that particular workload, and you start to capture that data to a honeypot to take a deeper look at what's going on. Or you can send that traffic and very transparently introduce a high-end firewall, again, to see, or finally, you can just quarantine that workload. So you can take all these actions by leveraging the policy-based infrastructure and the analytics, and the fact that when you have the right SDN infrastructure, when you are in the data path and have the ability to look at the data path in the data center as well as in the branch, because that's what you would have to do, then you can absolutely not only do automation in the private DC or the public DC, as well as the branch, but then you can leverage the centralized intelligence to strengthen and modernize security to make sure that ultimately it's all done to connect users securely to their applications consistently in a highly automated way. So the three things that are critically important, one is the visibility and security analytics. Second, about software-defined end-to-end segmentation. And finally, the dynamic security automation. All combined will deliver this modernized security infrastructure in support of SDN's endgame. Thank you very much.